Hello to all. In this lesson, we will learn how to work with distance ultrasonic sensors. Currently, this model is a HC-SR04. It's very cheap and not precious distance sensors, but it's more than enough to discover how work. So our logic, when we press the button, the distance sensor starts to measure the distance and emit it to our main thread. And at the same time, in a separated thread, it's still making a API request to weather API service. So it's starting measuring the distance, and if we press the button one more time, it stopped to measuring. That's all. Today it's our 8th lesson, and it's becoming more complicated and more interesting. So today we are going to work with ultrasonic distance sensor. Let's first of all, we need to know how it's working. Let's Google this sensor. So the model is HC-SR04. So this is very cheap ultrasonic sensors. Looks like that. How it's connecting, you can Google it as well. Connection. Connection GPIO. So yeah, this is a useful image for that. So as you can see, 4 pins in the sensor. One of them it's a 5 volt power, then ground, and 2 pins. One it's a triggering to send a command start measuring, and the second it's a echo. How we can calculating the distance? So here is the data sheet for this ultrasonic sensor. But be careful, very old models, like 5-6 years ago, they had 3.3 volts supply. So you can't plug these old versions of sensors directly to 5 volts. You can burn it. So be sure you have a new revision of this sensor. Here is parameters of this sensor: 15 degrees for measuring, maximum distance it's about around 4 meters, and minimum distance is around 2 centimeters. So here is the diagram how it's measuring. To start measuring, you should to send signal to trigger. Then after 10 milliseconds, it's starting to emit the distance. When it's sending a high signal, it's measuring. When it's sending a low signal, it's stopping to emit data, and the time distance between high and low, it means the measure, the parameter of measure. And here is the formula to calculate it. So we will work on very low physical level and implement it in our code. So Here is the formula with dividers to calculate in centimeters and in inches as well. Let's start it. First of all, we need to add distance sensor to our configuration. Here is an old configuration from the third lesson. I'm recommending to create another configuration and name it, 1 second, like something lesson 8. Distance sensor config. Okay. Then we need to add the name. Very easy to parse the configuration. Okay, then we need to add some sensor data to our configuration. Let's copy something from here, but it will be a distance sensors. It could be a list, a multiple sensors as well. What we need in our sensors, what data we need. First of all, we need name, distance sensor, HC-SR04. Then what we need? We need a hardware model. Hardware model. And we need a hardware version. Why we need to highlight the version? Because in all revision the voltage is different. Hardware, to avoid the conflicts, we need to specify very detailedly, to describe our sensor very detailed. Okay, so here is the version. We need, so we have two pins to send a signal and to receive the signal. So we need pin trigger, pin 24, then we need pin echo to listen the sensor and start calculating the measure. What we need, let's think about it. Just for example, if we have like RC car. So when we build our car, just for example, we can have a multiple sensors from different sides, from front side, from rear side, from left and right side. So we need to say our logic which sensor is emitting data. So we need a sensor position. It makes sense. We don't need a pull resistance, but we need a installed sensor position. By default it's 0. And what if we make one of the sensors or all of them with movements. So we install it to servo motors, and we can control and rotate our sensors. So we need some information in which angle specific sensors can moving. So it's just for safety. We will not implement this logic right now, but in the future, when we will build our RC car, this logic will be very useful. Moving angle. By default, it's 0 as well. Okay. We have a list of sensors. We can add multiple sensors. Now we need to parse it. So we have a configuration data class is here, but today we will create some new data classes. So I suggesting to collect it in one place. When we can store our data classes, what's literally instructions for our logic. Of course, in Brain package, we can create a data class, a package for data classes. And first of all, we need to move our configuration. So synchronize your code with this lesson on my GitHub repository, because we are going to move some classes to different packages, and you will have a compiling error of this. So refactor, it's refactoring with references to our data class, and let's add our distance sensor config. Okay, what do we have? We have a name. We have a hardware model. Hardware model, hardware version. We have pin trigger. Then we have pin echo. Then we have installed sensor position to parse all data from config. And we need to add this list distance sensor. Distance sensor. What a config 2 times. No, it's not make sense. Distance sensors. Yes. Okay. What do we need? If we decided that we can have different sensors, we can have a LiDAR, very expensive sensors, but it's more precious, or these cheap sensors is less precious. So we need an interface to group all the sensors and then make it more specific in our implementation. So of course we have a body, we have a hardware parts, we have 3 devices, 3 parts in our device. So let's create a shared interface, distance sensor, and let's describe it. What we need to receive to share two pins, pin trigger and pin echo. So let's describe it here, because in each our class we have digital inputs or outputs, but this is an interface, and we have to describe and then extend or override those values. Okay, trigger output, it's a digital output. Then we have echo input, echo input. This is a digital input. Then we need a Boolean state to check, is the distance sensor measuring right now and emitting data or no? So it's available to launch it. Is active? No. Boolean. Yes. And we need, as tradition, a coroutine scope to do all work in separated threads. So thread scope sensor west. It's a job. Okay. Then we need two functions. I'll explain. So from datasheet, it's saying that, where is it? Timing diagram. It's very easy. You only need to supply a short 10 nanosecond to pulse the trigger input to start the ranging. So we need to send a signal to start ranging, and then we need to measure, to define two states. Here is high state and here is low state, and the distance, time distance between those signals, calculating as distance using this formula. Okay, so we need to trigger output hatch, and we need to trigger output low. Now it's like a parsing the type of our sensors, because if we planning to add different types, we need to parse the data and create different sensors for different manufacturer. So we need to parse the data and define which sensor is installed on our circuit board. Okay. Logic for parsing sensor types. It's enough a companion object. We need constant val, the name of our sensor, name hardware model HC-SR04. It's the same like that. And version. Here you can add other sensor types if it's need. So we need to check which sensor is it, because if we not say something like that, so we're not saying what type of sensors is it, we can't use the datasheet from the specific sensor. So the configuration shouldn't be built. We need to parse configuration before it and make it decide, is it a valid configuration? Do we have a code? Do we have an implementation for these specific sensors? So let's make a func is configuration valid. We getting sensor config as incoming parameter, and we sending the type of our sensor. Here we can parse the configuration. I'll show you how we parse the configuration, because for example, what if we do this or like that, add comma, some useless, some symbols like that, or like that. If we do not parse the configuration, it will be different and we will not build this sensor. So we need to release our hardware model name from specific symbols, what not makes sense. Okay, if sensor config hardware model, let's filter not it. So we excluding like empty symbols to clean our hardware model name. We excluding those symbols. We can add it. What we need to exclude? We need to exclude this symbol. We need to exclude comma and dot as well. Okay. And we need to set it to lowercase, because for Kotlin this will be the different strings and different name model names. So we need to make it as lowercase. Then we need to contains to find the same name in our prepared configuration type for this. Okay, contains, and we should to do the same, filter it, filter not. I know it's not easy for understanding. You can just copy my code if you can't understand it. Then lowercase equals true, so let's check it. Filter not, then lowercase, then contains, filter not, lowercase, oh, here is it, yeah, return our hardware model name. Boom. We don't parsing a version of our configuration because it will be overloaded lesson. Let's do it when we need for different types of sensors. Okay, else if just preparing the place for parse add other types parsing, so it will be if else, or you can, if you will have like a 10 different types of sensors, what not make sense, you can convert this logic to when. Return nothing, else return nothing as well. Okay. I believe that's all. So if yeah, this one, return this one. Then yeah, like that. Return this one. Okay, that's all what we need. We already have our distance sensor interface. Let's make an implementation of our interface specific to our HC-SR04 distance sensors model. Okay, let's make a class. This, let's copy this name, distance sensor HC-SR04, and let's describe the version of this sensor. Okay, of course we need an incoming parameters. Let's copy it from here. We need a distance sensor config. We need a distance sensor config, and let's implement our members. Okay, we don't need this one because we can set it as late init vars. Override latent init. We set it when we built our sensor. From the configuration is active. By default, it false. And the job will be null. Perfect. Okay, init the instance of our class, build sensor. We set Pi4J distance sensor config. Let's copy this. Private fun, build sensor, sending the configuration. Let's make some checks. For example, if the pin should be not equals and not empty, not equals to null, let's create a function set trigger output Pi4J, and we need a distance sensor config pin trigger else return. Okay, pin echo, set echo input, echo input pin echo. Okay, let's create these two functions. Private fun, we need a pin for it, pin as int. So for output, of course, we need to build a params digital output, new config builder, build a config for it using Pi4J ID BCM. We're using a BCM plugging models to pins. You can read on internet what's the difference between BCM and board configuration when you're plugging physical input-output lines. Name, so we need a companion object for specific for this type of our sensor. So each class will have a different models. Name, hardware model, and we can copy it from our config, then version. Okay, name will be like name hardware model plus name hardware version and set our pin. Okay. Then most important, set address. No. Address. It's our pin. Then we need to initial state. When you initialize your digital output, you can set by default what it's emitting. We need to set it to low and build our trigger output. Trigger output equals Pi4J create not params, params. Okay, let's make this function, but for input we need to digital input, name, ID, address, but we can set it as it's not emitting. We need a pull resistance. Always set pull down resistance by default and build. Okay, echo. Yes. Then implement this function. Very simple function. So we have to trigger output, set state to high, set digital 1, and set state to low, digital 0. Yes, I believe it's all. It's ready, but it's a low level of our structure. We have a types, and this functions it's eligible from main thread. So as you can see, it's calling from main thread. So from main thread we need something to connect our sensors with main thread and our logic from avatar. So let's add new functions. Okay, fun, start distance measuring. Why we creating another function? Because main thread doesn't know which type of sensors is installed, and this information no need to main thread. It's just asking, please tell me what's the distance. And in our avatar we defining, okay, what's type of this sensor, how it's calculating, what's the function to provide the distance, and we send the data, emitting data, to main thread. So we need a bridge between our parts and our main logic. So we creating a function in interface and then just triggering what type of sensors, how calculating, and send the data. That's how we can use different types of sensors. Okay, start sensor measuring. We need a sensor position. Let's copy it, but not duration. We need a period. In millis. By default, set it to a half of second. So what means period? How often we asking the sensors the distance? Because if we do not set a period, it's breaking the thread and emitting data permanently, like each 1 millisecond. We don't need it. We need to ask sensor each second or each 5 seconds. It depends on your logic and how you're using the sensor. And when you use a RC toy car, if the speed is increasing, you're accelerating your car. The period of measuring should be shorter and shorter. If you stopping your car, you can measuring it more rare. So yes, that's why we including a period start, stop. And we need one more function to ask to know the information. Is the sensor measuring right now? Because if we attach the logic about start and stop measuring to one button, so if it's measuring, stop measuring. If it's not measuring, start to measure the distance. So we need to know get distance measuring state. So it's measuring or it's not measuring. The same boolean. What? Not button, distance, sensor position. Sensor position. By default. Okay. Perfect. Let's implement members, but before it, the step what we by tradition forgetting in our previous lesson. First of all, we need to parse a configuration. So we need to add distance sensors distance. That's how we can add different types of sensors. So each of our implementation extend the core interface. Okay, distance sensor, init button, no, of course, buzzers, then copy it, init distance sensors. Okay, but here is it a little bit different logic. First of all, before we need to check that all pins set it properly, and it's pin EHA the same. Okay, why we did all this ununderstandable code? Here we defining from our configuration when distance sensor is config valid, we sending our configuration and it's parsing from JSON. Okay, I know this model, I built the class for this model. If I don't know this model, I return something empty. Okay. GPIO, and if it's returning this name, we add to distance sensor the implementation distance sensor but specific, and receive parameters. Perfect. Then implement 3 other functions. Okay, now will be a little bit of math. Let's start. Some checks. If sensor position more or equals body sensor size, return false. Then we set our state to true to notify all threads that the sensor is working now and busy. It's emitting data. Okay. Body, distance sensors, sensor position, cancel the previous job. Then we build our job, separated thread, coroutine scope, job class dispatchers IO. Okay, then oops, sorry, I forgot. Here is the magic loop. No. Loop cycle while sensor is active. So if from another thread we set is active to false, all this logic immediately will stop to implementing. While body distance sensors, sensor position is active, this loop will be launched. Okay, return to our datasheet. Here is the right way to plug. This is a trigger pin, this is an EHAC pin, ground, and supply, power supply. So it's saying send a trigger to 10 nanoseconds. No, not for 10 nanoseconds. Send a trigger to start measuring. And after 10 nanoseconds, it will start to sending a data back to your code. So what we need, boom, boom, boom. Body distance sensors, get our sensor, sensor position, trigger, output high. This is a function what we implemented here. Then we need to wait 10 nanoseconds. So it's not a millisecond, it's nanosecond. In Java 8, it's provided new time units with nanoseconds, so you can't use the delay like that because it's a 1 millisecond, it's a 100 or 1000 nanoseconds each of them. So but we can use like that time unit, microseconds, sleep 10 microseconds. Okay, then after that we need to send another signal to activate the measuring. Trigger output. After that, the distance sensors will start to send the data, and we need to calculate it with using this formula, but we will do it in another thread. So we need to set some mockups to listen our sensor and change it. So AHA input is low. This is a mockup. We calculating echo low nano time system nano time. Then we listening when our sensor changing the state. And the time difference between those two values, this is our distance, because as it said, it's the sensor sending the short pulse, and the time in nanoseconds in this pulse signal, it means our distance. Very easy. So after that, we already know all the information, and we need to emit our data to all our project. Okay, in the package brain we have an emitters. Let's create another emitter. Distance emitters. Okay, and we can copy all this code from it because it's almost the same logic. Okay, but we need to create a new type for our distance data to calculate and know all the information. Actually, we can move. Okay, network emitters, we have a better data. Let's create a separated data class for it. Delete it from here. And import. Okay. And create a data class for distance. Distance. What we need in our data class for distance? Well, sensor position, because we can listen data from multiple sensors. Well, echo, where is it? It's a long. Okay, that's all. Oh, not all distance meters. Weather, we don't need this class. We need a distance. We need weather emitter, distance emitter. Distance data as distance, like that, emit distance response. Okay, let's check it. Distance emitter, emit distance, and we subscribe to this chart flow. Okay, perfect. Let's return to our logic and emit the data after we measuring the time in nanoseconds. Distance emitters, emit distance response, and build distance. Okay, sensor position, echo high, echo low equals to echo low. So echo high to echo high, echo low to echo low. Perfect. Okay, and add a delay before between measuring periods, because this while cycle will be in the loop with this delay. One measuring, second measuring, third measuring, until we set isActive to false state from another function. Okay, and from what function? Very easy. Okay, and return false. Body, distance sensor position is active to false. So from this function we stopping this while cycle, and from here return true and get the measuring state. It's very easy. Return if, let's make some checks. Body, distance sensors, size, we're returning body, distance sensor position is active, else we're returning false. Okay, perfect. Okay, what else we need? What else we need? Datasheet provided two formulas how to calculate. So we know only this time in nanoseconds and this time in nanoseconds. Let's create some logic to calculate the distance in centimeters or in inches. So, okay, no problem. Let's create some new package in our brain, because only the brain decides everything. Package utils and create a file, math utils. So here will be some math lab or lab math, I don't know how it's calling in English. Okay, so let's create a function for type distance. Distance to SM. But what we need, do not forget the parameters of this ultrasonic distance sensor. So we have a max range. What if we're returning something more than 4 meters? It means the measuring is wrong. So we need to set some protection to cut measures more than 4 meters. It means when we calculating the distance data class 2 centimeters, we need to know the type of our sensor. Sensor type, string, and add, okay, yeah. Const val, sensor type unknown, by default like that. Okay, I like Kotlin because it's very easy to extend any standard class or value or make some advanced function. For example, I can show you. You can make int some functions your open cell, like a int, I don't know, like a increase So let me show. We created our own function for standard int value. So wow. As you can see, very nice, very nice. We don't need this. I just type it, for example. Let's return to our function. Okay, and start our math lab calculation. Okay, when sensor type is distance sensor, we already have some types. Let's calculating our function. Okay, we have two parameters, echo high time minus echo low time, divide 1000, divide, we need this is a constants from datasheet from manufacturer of this sensor. Where is it? 58 and 148. Okay, let's add these constants to settings. Okay. Distance sensor HC-SR04 divider to SM. It will be a float value. $58 and 148. Okay, 2 inch 148. What we need? We need some protections if the measuring more than 4 meters, because here it's not so important. I believe 2 centimeters or 1 centimeters, it's not necessary for us. Okay, distance sensor max limit 400 centimeters. Max limit, or in inches, inch. I already calculated it, so it's a 158 inches. It means 400 centimeters. So if you divide, where is our calculator? If you divide 400 to 2.54, you will have around 158 inches. Okay, let's return to our function. Settings 2 centimeters, because we're using like that. Okay, then if the sensor type is, we should to predict all situation. Well, it's unknown. When we didn't set the parameter, it will calculate it, for example. And For else function, the same. Okay. But how we send the data only less than 4 meters? Very easy. Return if is in our value less than limit in centimeters, we send it. Else we can set, in Kotlin we have positive infinity, so we're sending something infinity. Okay, let's do the same function for distance class to inch, but the same, almost the same, only here we in inch, in inch, in inch, and here is in inch. Okay, the same type, but only different units, centimeters or inches. Maybe that's all, and we should to move to main thread. First of all, we already subscribe to weather data collector, so I suggest to exclude it to different, to separated function. Let's do it somewhere here. Fun collect data. First of all, exclude this data where it's ending, exclude it from here and move it to here. And now we need make it suspend. We need, so I'll show you. So I'm collecting data twice, but it could be different emitters. What idea study is selling? It's unreachable code, because when you're starting the collecting data, it's stacking in a loop, and this code never will be launched. So we need to collect this data in job coroutine, that's all. Job weather collector equals coroutine scope job plus. Why are using the different dispatchers? Actually, you can create some your own dispatchers by name, and then it will be very easy. For example, you can kill whole pool of threads with all subscribers, for example, for collectors, if you create your own dispatcher pool, and then you can manage it. But it's too complicated for our logic. Okay, and here, boom, perfect. We don't need to suspend func anymore. Okay, and let's, here we can subscribe to another collector. Let's create another job weather job distance collector. distance emitters, distance emitters. Distance, no, distance sensor. I don't like this name. Okay, distance sensor, collect, set a distance, okay. And how we can know is the measuring is valid or it's infinity? Because it can emit positive infinity. It means the measuring outside of the sensor parameters. So we have to check it. If distance to is sim and set distance sensor our model equals to float positive infinity, we printing out something distance is out of measuring, and else we print out our distance. Let's copy it. Distance equals distance 2 centimeters set it, and of course launch our collect data. Okay, so how we launch our function? So let's do some logic. If we're getting our avatar, if our avatar get distance state, we don't need to define sensor position because it's a single, but if it's true, it means it's false, it should be true. Revert it. Avatar body start measuring, and we period and millis set each 1 second it should emit data, else if stop the measuring, else stop the measuring, stop distance measuring. Okay, what it means, when we press the button once, it's defining is the distance sensor measuring right now. If not, we start measuring. If it's already measuring, it's stopping measuring. Let's launch our code, but I believe, oh yeah, network emitter, weather data. Okay, because we move weather data to the separated data class in our brain. Just to make structure more simple. Increase. Okay. Okay, let's look if our configuration with distance sensors is parsing, was parsed. Just wait. Okay. Pin echo. Pin echo. We need hardware. What's happening? Yes, of course. Pi4J say that it's trying to set pin, the same pin 2 times. It's not make sense. Pin trigger, it's a pin 25, and pin echo, it's a pin 24. Very good runtime error, actually. You can see we can add more, one more check, but you can see how it's parsing and logic step by step. Okay, first of all, our configuration. Yes, we have one sensor. It's parsed. So now I'm going to press the button and you will see. Is it measuring or no? Okay. Yeah, it's measuring. So now I'm going and will stay near the sensor and you will see. So now I'm staying around maybe 30 centimeters. Now it's around 10 centimeters, like on my eye. It's around maybe 5, 4 centimeters, 6, like that. Now it's around 1 meter. So yeah, and you can see but I believe we did something wrong because the calculation is wrong. Why it's wrong? Let's go to the math utils. So echo high nanotime, echo low nanotime, divider. Oh, we make a mistake. We make another mistake. Divider in centimeters. Boom, boom. In inch. Let's relaunch it because the measuring is wrong. You can see how easy to make a mistake in MATLAB. Because now it should to emit infinity. Because now I'm not staying near in the front of the sensor, so it's out of measuring. Now I'm going to the sensor. I'm around 1 meter in front of sensor. Now it's around 50 centimeters. It's around 20 centimeters. It's around maybe 10 centimeters. It's around maybe 4 centimeters. Yes, as you can see, 4 centimeters, very precision measuring. Here, as I said, 30 centimeters. It's around 1 meter, because like that. It's working. Then I press the button one more time and it will stop measuring. It's stopping the measuring, but it's another request to weather data. So, as you can see, all our working parallel in separated thread. So in one button we add the logic to make an network calls and work with physical distance sensor and everything in the same time. I'm very glad that all works as expected. Today it was a long lesson, but I want to cover all the logic and all the information about this distance sensor. So one more time, use data sheets. We worked on the physical level to use provided formulas to calculate the distance using 2 timestamps between high and low signal, and we add the configuration to our avatar. So now if we add some engines and more sensors, we can build autonomic RC car with autopilot. Just add this logic to our brain package. When we use some AI features from TensorFlow, we can work with video signal from video camera and search some objects and move to them. But before it, we should learn a lot of things from physical level and best practice for Kotlin coding. That's all. Thank you for your attention, and let's see you next time.